Okay, so let's have a go. Let's freshen this up. I'll switch this, start a new document. Okay, so we need to sketch the derivative function. We're given a derivative this time, so we don't need to find the derivative, we just sketch it. This is going to be bracket 8 over x, 8 over x plus 2 minus 1.
You forgot the square.
Tab, move up, squared. So the function looks like this. What's interesting in a derivative function are the x-intercepts. We can't see all of the x-intercepts, so I'm going to adjust the window settings. Menu, window, window settings. Let's go to minus 12 or so we see that one. We also don't need to see so much on the y-axis. I'll just zoom in a little bit there, change those to plus and minus 3, because we're really interested in these 2 points. So firstly, we're asked to sketch it. So to draw the sketch of a derivative, the curve looks like this. There's a vertical asymptote there, and it looks like this here. We've got horizontal asymptotes here. What's interesting in this function are these points here. This is, we can see, minus 10, and this here is, we need to find that point there. Let me just do menu, analyze graph, 0, scroll either side, lower bound there, upper bound here at 6. So this one is at minus 10, comma, and 6, comma 0. So this is sufficient for, this is y equals f dash of x. The x-axis, that's the y-axis. We've got our sketch drawn. That's A. So for B, which one of these two represents a maximum? Which one of these two represents a minimum? So we need to find out which one is a maximum. So for a maximum curve looks like this. Is the gradient positive or negative here?
Negative. Positive.
So we need positive. What about here at the top?
Neutral, 0.
0. And here?
Negative.
We need to find where the curve, where the derivative is positive, negative, and then 0. So the derivative is positive here. This is where it's positive. The derivative is negative here. So we want it to be above the x-axis, through the x-axis, and then below the x-axis. Is that at 6 or at minus 10?
6.
At 6. So here at 6, at x equals 6, we have a local maximum point. At x equals 6, we have a local maximum. Why?
Because the graph also goes negative.
Because which graph?
The derivative.
The derivative changes from positive, positive to 0 to negative. That's it. So So we simply look at a derivative and see where it goes positive, 0, negative, and say there's a maximum there. Where it goes negative, 0, positive, there's a minimum there. So next we need to say in what intervals is the function rising? In what intervals is the function? We don't need to say falling, we only need to say rising. So what I'm going to do is I'm just going to get a little dotted line here. So a little dotted line through there, a little dotted line through there. So there is no derivative down here. There is no derivative up there. See that the derivative is in these three spaces. In what interval is the derivative in the green space? Negative 10 to 6. And in that interval, it's positive. So it's rising. So in that green interval is where the original function will be rising because the derivative is positive. In these two red intervals is where the original function is falling because the derivative is negative, not the function. So in the red intervals, the derivative is negative. The original function is falling. Now this function is a little bit trickier. So we can't quite answer it in C. We would like to, so where am I? Pen. We would like to answer for question C minus 10 to 6. But we can't. When the function goes up like that, it has a vertical asymptote. So if I do the window settings now, and I let the y values go up to 300, minus 3, tab 300. Look, it's going up to a point. It's going up to a vertical asymptote. So there is no value at that asymptote. Where is the asymptote? The asymptote will create a divide by 0, because we can't divide by 0. What value of x will create a divide? Negative 2.
So it's reaching there forever, but it's never actually going to be negative.
So here on this one, the answer is in that interval, but not there. And that's the easiest way to answer it, because we have that vertical asymptote.
But how do we get negative 2?
We get negative 2, we can see it here on the graph, but not that precisely. The easier way is the vertical asymptote is caused by, you can never divide by 0. So if we take a rational function like this one, and we find what value of x will make the denominator 0, we take the denominator, set it equal to 0, and solve. Typically, the IB on these questions will give you it in the statement of the function. So when they give the function, they will also say x is not equal to negative 2. You have to notice that tiny little bits. Those bits that come in the question after where they give the function, they usually say x is this or k is a positive integer. You have to read that, those little bits, because you can use them.
Could you also read it as just parentheses, negative 10, 6?
So an alternative way to do this using interval notation is we don't include negative 10, so we use that one, up to negative 2, union negative 2 up to, but not including 6. So you can answer with interval notation using this.
But it's not going to ask for specific notation, right?
No.